Hello everyone. In this video tutorial, we're going to go over some R best practices. Everything that we talk about in this video today are issues that pertain to R programming beyond Shiny apps. The reason that we're bringing them up independently is that the more efficient and easier to read we can make our R code, the more time we can spend designing engaging apps and the less time we'll have to spend debugging. So before we really get going here, I just want to draw your attention to the written tutorial available on our workshop website. So if you prefer to learn some of this content in written form or just want to have something to refer to later, that tutorial is there for you. There will also be some parts in this video where I'll skip over some more fine details that aren't really relevant, so you can refer to the tutorial to see all of those details. This tutorial is really informed by this quote from Martin Fowler, who's a well-known computer scientist. Back in 2008, he said that any fool can write code that a computer can understand. Good programmers write code that humans can understand. And that's really going to be our driving motivation here, to write code that not only works well from the computer side, but is an enjoyable experience to read and work on from the human side. So the strategies that we're going to pursue to make our code nice and readable to us as humans and a joy to work with is to make our code descriptive, consistent, concise, visually human readable, and accessible to a wide variety of users. Now, for the rest of the lesson here, we're going to denote our best practices. Those are the things that we can do to make our code easy to use for ourselves and others with this smiley face emoji. And we're going to denote our less than best practices, which are those sorts of things that we all do, but we would like to maybe start to grow out of with this frowny face emoji. Now, before we dive into the code, I just want to take a moment and show you all what libraries I'm going to use. You don't necessarily have to code along with me for this lesson because I'm going to intentionally show you some bad code. And I would hate for you to spend muscle memory on replicating bad code. So just so you know, we'll be using the tidyverse packages, which is of course the group of data management packages that all comes together in the tidyverse, as well as the Wingspan package, which has bird names and statistics from the Wingspan bird card game, and the colorblinder package, which lets us simulate what our code and graphics will look like to people with different forms of color blindness. So the first thing that we're going to talk about in terms of actual code is naming things. So this will apply to when we name individual variables, like we might do for a reactive value in Shiny, but also for naming things like data frames and functions. And when we're using any kind of name, especially for a data set, we want to make sure that our name is descriptive, concise, and consistent. So now I'm going to walk through some code examples, and I'm going to show how different naming strategies either live up to that best practice or maybe have room for improvement. So the first thing we're going to do is extract some data about the bird cards from the Wingspan package. And we'll make two data frames, one called data1, styled with an uppercase D and no space between the letters and the number, and data2, styled with all lowercase letters and an underscore between the letters and the number. Data1 will contain just birds that have platform nests, which we'll extract using the filter function from the dplyr package, and data2 will contain information just about birds that have cavity nests, which we'll extract the same way. So if we think about our objective, which was to make sure that our variable names are concise, descriptive, and consistent, these names are certainly concise, they're nice and short, but they don't tell us anything about the data inside the data frames, and they're stylistically not consistent with one another. And neither of those two things is a huge deal when we just have two data frames, But once we start scaling up, if we're able to just skim along and tell something about our data frame based on its name, it's going to make any debugging that we have to do go a lot faster. And when you spend as many hours looking at code as I suspect that a lot of you do, it's just going to be a much nicer reading experience if we're using a consistent style and it's just smooth and easy to skim. So if we are just focusing on that consistency and making concise names, one thing that we could do is just use data_1 and data_2. And that's perfectly fine. And now it's consistent. And the computer will read these two sets of code exactly the same way. But it still doesn't tell us anything about what's in those data frames. So one solution is to use our snake case format here, which is where we have lowercase underscore lowercase, to name our two data frames, platform nesters and cavity nesters. That tells us what's in those data frames and what we used to determine how we were splitting them up. So that's all fine. I think that's very consistent logic, and I suspect a lot of you already do things like this. But what if I had to put my project down for a month or 6? Because as we've all learned in the years 2020 and 2021, life does not always go according to plan. Well, if I was picking this project up again in 6 months, I might be sort of bewildered, even if I had put a lot of thought into it on the front end. And that's why one of the kindest things that we can do for ourselves as programmers is to write clear and abundant comments about what we're doing and why. So things that you might want to include in your comments are the functions you're using and what packages they're coming from, why you made certain decisions, and how the parts of your code interact. So I know everybody probably writes comments, but one way that I like to think about comments is kind of like if I'm writing postcards to somebody who might see my code later. It should just sort of give an instructional snapshot of what's going on so that they can pick it up and use it and carry on with that without having to ask me a lot of direct questions. So moving on from naming things and leaving ourselves comments, one of the big things that I would really recommend you spend some time thinking about for the kinds of code that we're going to write for Shiny apps is the visual wrapping of your text. So here we've taken our filtered bird data frames and we're adding another step, which is we're using the select function from the dplyr package to select a whole series of columns. And the data in these columns is just more variables from the card games. It's not super important for our actual work here. So again, the computer will read this all just fine, but for me as a human, reading this is really overwhelming. And if I've missed something like a comma or a space between words that shouldn't have a space, then it's going to be really tough for me to visually skim this and figure out what's wrong. And there's, just to give you an idea, in case you were on the edge of your seat wondering what this data would look like, there's the first 5 rows and columns. So I would really encourage everyone, especially when we get into more complex data operations, to consider this vertical layout, because not only does it make it easier for us to visually skim, if you want to comment out lines to test the behavior of a piece of code, it's going to be much nicer and easier to do that if everything's laid out vertically. The other thing about using a vertical layout like this is that because R doesn't really read spaces in the way that some other languages do, we can use indenting to give ourselves messages about the structure of our code. So we can kind of like use indents to impose a hierarchical structure on our code, which will help us sort of work through the steps that we're taking when we have to pick up our code again later after putting it down for a while. The next thing I want to talk about is what happens when we have to repeat ourselves. So up until now, we've been doing really simple operations, and it's totally fine to just have it all written out in a script somewhere. But what if we needed to do the same operation multiple times? We could just write out 2 code chunks that do the same thing, And this code chunk does this process where it makes a summary table that we've calculated the efficiency of eggs returned per bird in the game relative to the number of food items you need to pay to put the bird on the board. But I really don't see any reason why we should be doing the same thing twice. It clutters up our space and it creates opportunities for us to make mistakes. So, the strategy that I'll encourage us to take, and this again is going to become particularly helpful when we're writing Shiny apps and there's a lot happening in our workspace, is to write functions. So in this case, we're defining a function called calcegf, which means calc egg efficiency, and note the concise and descriptive function name. And we're going to write a function that does exactly what we just did, where it calculates the efficiency of eggs returned per food item paid. And you see that once we define that function, we can then just apply it to our code block like we would any other function. And we can just make our summary tables an automation, and our ultimate script ends up being a lot cleaner. Especially if we are in the sort of situation where we do lots of custom operations like this, and we can write a series of custom functions to a script or even to an R package, which I would actually recommend you check out because it's not as difficult as it sounds. And then we can just source our own functions and use them like we would any other R package. The last topic that I want to tackle today is accessibility. And this is a big topic. So I want to be really clear that we're just barely going to scratch the surface of it here. So to show you one way in which we can help make our code and our data output more accessible, we're going to make some plots. So here we're going to make a plot that has the bird's wingspan on the x-axis and the number of victory points that that bird is worth on the y-axis. And then we're going to vary the color of the point by whether or not the bird is a predator. So birds that are predators will have dark green points, and birds that are not predators will have dark red points. And folks who know anything about ggplot and anything about accessible design, I just want you to pause a moment and consider whether you think this is going to be a smiling plot or a frowning plot. So here's our plot. And besides the obvious design updates that we could make to it, it looks relatively okay, unless you have any form of color blindness, in which case this plot is going to be really hard to make sense of. So one of the absolute easiest things we can do as programmers is that whenever we're using color to convey data, which again is something that we're going to end up doing a lot in Shiny apps, we can think about choosing colors that are interpretable to a wide range of humans. So I've revised our plot here, and you can see that I'm using Scale Color Manual to choose some colors that I've compared and picked out ahead of time to be colorblind friendly. And one way to know that a color set is going to be colorblind friendly is if, in addition to varying in hue, which is what we tend to think about as colors, things like blue versus green versus purple, our colors are also varying in value, which is the amount of black in the color or how light and dark it is. So this time around, we've chosen colors that have both different hues and different values. And then we're going to do some other things that both make our plot nicer and simpler to look at and easier for a wider range of people to read, because we're going to make our text quite a bit bigger all the way around, which makes it easier for a lot of different kinds of folks to read that plot more quickly and easily. So if we look at our revised plot, we've got bigger points, bigger text, and we notice that there's more contrast in the value of our colors. And if we run that through our color blindness simulator again, we see that it's way easier to read for anyone who's got any sort of color blindness, or even anyone printing on a black and white printer. So just to sum up, when we're thinking about code that expresses best practices, we're working towards code that is descriptive, consistent, concise, readable to lots of different humans, and making an effort to be accessible. As I mentioned earlier, we've sort of really only scratched the surface here in terms of basic R best practices, Most of the concepts that I talked about in this video come from books like R for Data Science and Advanced R, and even the Mastering Shiny book, all of which are fantastic and available free online. We've got links to them on our resources page of our website. And I would also really encourage you, if you've never looked at videos from the Consortium and R Studio on YouTube, I would absolutely check them out. There's some really cool videos thinking about everything from the philosophy to the engineering of R code. And I would especially encourage you, if you can find any talks online by Jenny Bryan, to check them out. She's a software engineer at R Studio who really thinks deeply about the structure, efficacy, and ethics of R code. So thanks everyone for listening, and I'm really excited to see how you all work through best practices in your R code.